In this video, we're going to learn how to better understand end conditions and use them effectively in the design process. To start, we're going to be in our template editor, and I'm going to do a right click, and we're going to place our very first end condition to begin to explain and understand how the different properties work. So I'm going to select the new end condition, and I'll just put in a name here called fill and a feature assigned to the end condition, and I'm using the examples workspace. The basically surface feature here, what this does is controls the level, color, style, and weight in the three-dimensional model as well as the material assignments. The other thing that we have to take a look at is targeting. We're going to talk about targeting in great detail in just a little while. So I'm going to come in and place this first end condition, and I can use precision input or dynamic settings here if I want to, and I can say to start at 0, 0, enter. And at that point I can use dynamic settings to place my next point. I can give it a new point name, whatever I want to do, or I can just place it out here. I'm going to choose to use horizontal and slope, and I'll just say I want to do 4 feet, and I want to do a slope at -1:4. And so we'll enter that, and then I will right click and finish, and that dynamically places our point. Of course, you can go in and modify where this is at, this second point, but this is what we want to start. What we want to start with talking about end conditions is what are they, how do we edit them, and what changes do we make? Do we make the changes on the points? Do we make the changes on the segment or segments? Do we make an end condition as one continual segment or multiple segments? And these are all things that we're going to explore. The first thing that I want to really get into are the properties of the points that makes up the ends of the different segments of the singular end condition or multiple end conditions. So if we come into this point, this essentially is a child. At this point you see the red, which means it has right now 2 constraints on it. This is the child point of this parent point. And so I'm going to call this, rename it to fill so we can talk about it a little bit more than hinge versus hinge 1. And so we have this point name called fill down here. And we have some special properties that are not available to us on a normal component, these end condition properties. We have check for interception, place point and interception, end condition is infinite, and do not construct. These particular 4 properties need to be explained in detail. The easiest way to explain them is to first turn them all off, apply those changes, and then do a test. What the testing mode does is it allows us to show the target and how that end condition reacts. And so our target right now, we'll talk about targets in just a minute, so kind of bear with me, but our target is right now our active surface, or essentially our existing terrain model. And so if I draw that, it doesn't matter where my existing target is or where my target shows up. Is it intersecting this piece of this end condition? Is it above it? Is it below it? The mere fact that I've turned off all the properties on that bottom point, the only test then that takes place is the active target present where the end condition is? And so I'm not checking to see if it intersects it. I'm not placing a point where it intersects. I don't care about infinite. The only thing that we're doing here is we're drawing this segment no matter what, because the target, the active terrain model, is present in our testing window. And so if we come back in here to our properties, and then the next thing I want to do is I want to turn on only the check for interception. So check for interception. We'll apply that, and then we'll test again. And now what happens is when we draw our target, you can see that it draws as long as the target intersects the end condition. And so as soon as I come off of the end condition segment, which remember I drew that 4 feet at a 4:1 slope, as soon as I come off of it on either end, it doesn't intersect it anymore, therefore it can't draw. Let's go to the next property. The next property is to place a point where the 2 intercept. And so we apply that, And we'll close. And so now, no matter where our target is at along that segment, as long as the target is present and it's intersected, it will then place a point where it intercepts the target. And so that's what the next toggle does. Now, as soon as I come off of this in either direction, it fails because it doesn't intersect, and we're checking for the intersection with our active target. So let's go now to the third property, which is to make the end condition infinite. So I'm going to apply that. And so now when I come back and do this test, we have our check for interception working. We're placing our point at our interception. But what happens now is we can now extend beyond, and you'll see the offsets there along the bottom. We can extend beyond the original drawing location, which was here, as far as we want to, and then that will process. Now up here it will fail because we have established a direction the end condition is supposed to solve, which is going to be down and to the right. And so therefore up here the infinite does not do anything, but down here it does. So we'll close that out. And then the last property, I'm going to reserve talking about that one for a little bit, the do not construct. But first I want to get into the individual legs of the end conditions, what they do, and how they operate. So let's now talk about this particular segment. I'm going to double click on it and go into its properties. On these properties, the main thing that you're going to look at here is the fact that we have this new section that is not on a normal template property called end condition properties. Essentially what we're defining here are the targets and priorities and benching. Essentially, for an end condition to draw, it must find its target. Now, how it finds its target and what it does when it finds its target depend on the end of the end condition point's properties, which I just demonstrated. And so the different types of targets we can hit with our end condition segment is a terrain model. Typically that's like your existing ground or your active surface. It doesn't have to be your existing ground. It could actually even be another, like a proposed terrain model. Maybe you're targeting, for example, a bridge berm, or a bridge abutment. So you don't have to target the existing ground. Essentially, it just needs to be a microstation terrain model, and then you have a choice in here. You can pick whatever the active surface is, or you can put in a specific name. And when you go in here to edit your end condition, every terrain model that exists in your drawing will be listed in this drop-down. So you can target a terrain model, you can target a specific elevation. Typically this is useful when you're doing work like, for example, in detention ponds, where you, for example, may need to hit the theoretical high water mark. So you could put in a specific elevation and target that elevation. The other types of targets, really there's two categories. You can do a linear target, which is essentially an alignment. So for example, you place civil geometry in your drawing that represents toe of ditch, and you want to follow that toe of ditch. If you come in and assign it the linear horizontal, it will hit that horizontally. If you do vertical, it'll hit it vertically, assuming that it has a profile, or you can do both. And there's special circumstances on how we target these linear alignments, and that'll be towards the end of the video when I talk about targeting within conditions. So we can target an alignment, which is an efficient means of controlling where our end condition ends, or we can also target a feature definition. Essentially, targeting a feature definition does what targeting an alignment does, but when targeting an alignment, you key in a special or a specific name, and your drawing will be scanned, or in finding any alignments in there, or you will type in an alignment name. But when you're targeting a feature definition, you can see every linear feature definition available in your workspace will be listed as an option. The differences really are in terms of optimization of the speed at which your model processes. If you're targeting a linear alignment, whether horizontal, vertical, or both, that has a unique specific name. So when we go through each cross section, it looks for that particular name. If it finds it, it goes to it. If it doesn't find it, it doesn't. That's very straightforward. There's no scanning of, thousands of potentially thousands of different alignment names because it's keyed in as a specific alignment. However, if you target a feature, for example, what happens if you have 20,000 lines in your drawing all with the same feature? That means every cross section that it goes to process, and you have this set to feature, it has to load all 20,000 of those elements in that have that same feature, scan through all 20,000, figure out if it intersects it, and then draw to the one that it intersects. After it gets done with that particular side of the cross section, it goes to the other side, assuming that's on the other side in condition as well, and it does it all over again. Then we go to the next section and we start over. And so again, if you have a small project targeting a feature or an alignment, really you're not going to notice any speed differences in terms of model processing. But if you have a huge project with a lot of different particular elements with the same feature assignment, targeting a feature is really going to slow you down. And so it's always best practice to target a linear alignment if you can. So in summary, we have a lot of different targets the end conditions can hit. But the one rule that you must remember, in a segment of an end condition, which is what we have here, can only hit one target. Only one target. So let's ask this particular example. What happens if you wanted to target proposed right-of-way and you wanted to tie the proposed right-of-way to the existing ground? In other words, we want a fill slope that finds the proposed right-of-way and finds the existing ground. In that particular situation, you really have two targets. And so what we would have to do then is to construct two different end condition segments. One segment would find the right-of-way target, and the other segment would then find the active terrain model. This is where we will introduce the do not construct concept. So let's take a look exactly at how this would work. We have our particular test case here, and just to review, that is coming in and finding the active surface and it's working fine. But what if we wanted to override that slope and have it tie at the right-of-way? So what we're going to do here is we're going to start a new example. And so I'm just going to do an edit clear here. And I'm going to place my first end condition component. And what I'm going to do for a feature on this one, I'm just going to use like a draft do not construct. And I'm going to call this one right-of-way seeking, or right-of-way seek. And instead of targeting a terrain model, I'm going to target linear horizontal. And the target name, I'll make up a target called right-of-way. And that's what we would need to have in our project. And so I'm going to begin to place this first segment. And I'll come in, let's say that we put this at 0, 0. So we'll start it there. And I'll just stay with the 4 feet. So we'll go horizontal distance of 4 feet and a slope of 0. And so there's our first segment, and we will finish that. And so now when we come in and test this, essentially we should be following that alignment. And you can see we need to make a couple of adjustments here on our point and how it seeks. And so number one, it needs to be infinite. We definitely want to make sure that we see it, and we want to place a point where it's at. And so we want to turn those 3 on, apply that, and test. And so now, no matter where we're at, I'm going to scroll over here, you can see we go well beyond the 4-foot test or come into the, up to 0. As long as that target is present, then horizontally we end where we see that right-of-way target. So far, so good. Now the next thing we need to do is we need to find where the ground is, or where our active surface is, where that right-of-way line is found. And so I'm going to come in to do that. We're going to add another end condition. And again, I'm going to use the draft do not construct. And this time I'm going to call this as, we'll just call it EX ground seek. So that'll be the name. and we're going to target our active terrain model. Now what we're going to do here is we are going to basically add on to the end of this with a new end condition. And for this one, I'm just going to do a change perhaps of basically a delta from our last point, and we'll say 0, minus 4. And you can see basically we're essentially drawing the right side of a box, if you will. We came over 4 feet, and now we're coming down 4 feet. And so I'm going to right click and finish. And so let's take a look now at this end condition is targeting our active terrain model. This end condition is targeting the right-of-way. And let's go ahead now and change these properties for that to also be infinite. We want to place a point at the intersection of its target, and we want to check for making sure the target is indeed present. And so we'll apply that and close. And so now when I test, I have to have both targets present. So if I draw my existing ground, you can see that nothing solves. Remember, for an end condition branch to work, and we have a branch here, we have 2 segments. Every end condition segment must find its target for it to process. And so we have placed the active terrain model, which satisfies the target for this segment, but we have not yet placed the right-of-way alignment, which is the target for this segment. So if we add then the second target, now you can see we are finding both targets and it is reacting as expected. Now obviously that doesn't complete our assignment, because our real assignment is to draw essentially a fill slope from our starting point to our ending point here. And so how do we do that? What we're going to do is add a simple regular constrained component connecting these 2 points. And so I'll right click, I'll add a new simple new constrained component. And this one we're going to call fill slope. And we'll just give it a name here to right-of-way. So fill slope to right-of-way. And I'm going to give it the proper feature definition called grade fill. And I just need to connect these 2 dots. And I don't want it to be closed, and I do want to finish. And I'm getting to that menu by right clicking. So now let's see where we're at. When I test this, notice how this is always drawn because it is a regular component. And so as I draw my targets, you can see that I essentially have it right, but I don't want this to draw if the targets aren't found, number 1. And number 2, I don't want these purple lines to be seen. So how do we make those changes? Well, the first thing I want to do is only draw this green line if these particular targets are met. And so I can come to the property of this standard component, and I can assign its parent component as the one that looks for the right-of-way target. And so if this one passes, then I know it's okay to go ahead and draw this. And it's understood that if both targets aren't found, this won't draw anyway. So we don't really need to worry about the fact that it's really tied to both of these. We can just tie it to one of them and it'll be fine. And so by making that change, when we come back and test, here's our active terrain, and you can see nothing is drawn. And then we add this target. You can see now that our fill slope is properly drawing. So the last thing we want to do is to get rid of the purple lines. This goes back to the 4th property right here, is that we want to tell it do not construct that point. So it goes ahead and solves it. It simply just means don't display it. So I apply that and hit OK. And now when I test, doesn't really matter which target I place first. So there's our active surface target, and then there's our right-of-way. You can see now that with both targets being found and the do not construct property assigned, this is actually drawing exactly what we want it to, that it's drawing a fill slope to the ground meeting at the same offset as the proposed right-of-way alignment. So based on what we learned, now comes a test. So let's go ahead and clear this off. And I'm going to essentially draw two ditches. And I want you to think about what I'm doing while I do this. And so the first ditch places an in condition. I'll just call this ditch 1. And I'm going to put in here an assignment called grade cut. And we'll keep our target type. And I'm going to come in, we'll use our precision input here. I'll start out at 0, 0. And let's draw a ditch 4 slope here. And so I'll come in and we'll come into horizontal. Let's say we do vertical. So we want to do a vertical of -2, and then we want to do a slope of -1:4. So there is our ditch 4 slope. Now we're going to do a ditch bottom. So we'll go over 2, 0. There's our ditch bottom. And then I'm going to come up at a 3:1. So again, we'll do there's a number of ways that you can do it, but we can do let's do a horizontal slope this time. So we'll do a horizontal, we'll come over, it doesn't really matter, a couple feet, and we want to do a 1:3, 3:1. And so we'll right click and finish. So the first thing I want to point out here is what I constructed is essentially from this end condition branch point, one end condition, because if I toggle this end condition, and you can see it here in the active template mode, if I come over to end condition branches, see how the whole thing's highlighted and it's called ditch 1? That means that I would have one target. And so if I click on this, you see how the whole thing highlights and I can assign one target. And so if I test this right now, you can see that it's met the target on the first section because I haven't changed the properties on the endpoint of the first segment or the second segment. So therefore, it thinks it's done on the first segment. So how do we fix this? And how do we make the 4 slope in the bottom always show up? Well, again, it's very simple. We just go right back to those properties. So on this first section, I don't want to place a point where it intercepts. I just want it to draw that. Now you could, if you want to, and I don't even really need to check for an interception. So we'll apply that change. And then we're going to do the same thing here. Apply that change. And notice that I didn't even have to turn this off. If you don't check for interception, then obviously you can't place a point at the interception. You can or cannot turn it off. But if you're both off, you can just hit the top one. And then on the last one, we want to come up here and we want to place a point of interception, check for interception, place a point of interception, and make it infinite and apply that. And so now what happens is if we test this, you can see as long as it finds its target, right? As long as it finds its target, it will solve that ditch. And so you can see now everything is working as we would expect. But what happens if I draw the same picture, same layout, but I draw 3 individual segments? Let's do that. So I'm going to come into end condition, and I'm going to say segment, I'll call this 4 slope. So that's our ditch 4 slope. And we're not too worried about our features here. But what I'm going to do is I'm just going to kind of pencil this in out here, or we can use precision input. It doesn't matter. I'm just going to say x is 0 and y, so comma -2. We'll just drop it down a little bit. All right, so there's our first point. And we'll do, I think I did a vertical and a slope. And so we did a vertical as -2, comma, and then I did a 1:-4, and then that lays that point out. And then I did a horizontal of, now, see what I did there? I was going to continue that. Actually, I want to finish. Now what that did was that makes it, what? Its own target. So now let's do another end condition coming off of this point. And this time I'm going to call this one, we'll call this ditch bottom. And I'm going to come over here for this one, We'll do horizontal is going to be 2 and the slope 0, enter. And then lastly, we're going to do the 3-to-1 back slope. So I'll do a right click finish. We'll do add new component in condition, and I'm going to call this our back slope. So there's our back slope. And we'll come up, start off here. And then I'm going to do I believe I did a horizontal in slope. Doesn't, like I said, it doesn't really matter. I think I came over 2 feet and I came up at a slope of 4-to-1. So we can do a horizontal of 2, and then I'm going to do a slope here. So I'll do a comma 1:3, enter, and then we'll finish that. And so these look exactly the same. But when you think about it, what's different here? Well, what's different is I have now 3 segments. And so in my active template, you'll see if I go to my in condition branches, this is one in condition called ditch 1 that has 1 target. But this hinge point, or what we call an in condition branch called hinge 4, has basically children. So the back slope is a child of the bottom, and the bottom is a child of the foreslope in terms of if this one doesn't solve, this one's not going to solve. So for this one to work, all of them must find their target. Well, what is their target? Well, if I go to each of these, right, by default, it's going to the active surface. And so if I hit test here, and we know the top one's working, but nothing happens in the bottom, okay? And why is that? Well, if we go back here and look at this first one, and we're going to edit that point at the bottom of that foreslope, and what we're going to do is just going to tell it to just always draw. So we're just going to turn off the interception, and because we did 3 individual segments, we're not going to make it infinite. We're just going to say always place that portion. So we'll apply that. We'll do the same thing here. Make those changes. And then on the last one, we'll come in and make sure that that is set to infinite and apply that. And so now when we test, you see our top one and our bottom one are going to react exactly the same based on those properties. But the differences are, by doing this, we allow ourselves to have 3 targets instead of just the 1 for the back slope. And so different ways to essentially come up with the same type of model, but this second approach gives us a lot more flexibility. The next thing we want to talk about are priorities. And so what I'm going to do here is I'm going to do another clear here. And I'm going to pencil in a couple of different fill slopes. We'll call the first one fill slope 1, and I'll set an appropriate feature for that. And we'll use our precision input. Try that one more time. And we'll start at 0, 0. And I'm going to put in a horizontal. So we'll do a 4, comma, 1:-4, enter. And so there is fill slope 1. It is a 4-to-1 slope. So we'll finish that. Now I'm going to add another in condition, and I'm going to call that fill slope 2. Keep everything else the same, and I'm going to start it at the same in condition branch point. And this time, I'm going to do a horizontal of 4, but I'm going to change the slope 1:-2, enter, and finish. And so what's going to happen is when I test this, I'm going to get an error. The reason I'm going to get an error, think about what would happen is if the target, the active terrain model, cut through this particular section. So test, we're going to get our error. And then when we draw our target, it's just going to pick one. Okay? And so to fix the error, we have to go to check priorities. And it says, hey, I found a conflict, and we do edit. Well, it says you have both of them set to number 1. Well, here's the deal. the lower the number, that's the order in which it processes. And so right now it's trying to process both of them at the same time. And so if I want to check my 4-to-1 slope first, I leave that set to a priority 1, and then as I highlight, let's check the second one second. And so we'll call that number 2, and we say OK. We can close, and so now when we draw our target, you can see as long as it intersects our first fill slope, it draws that one. But as soon as we get to the second one, then it solves that one. And so to finalize that, we can come over here and set that to infinite, and this would be a valid fill slope solution. And so we come over here, and you can see it gets to the end of this one, and then jumps over to this one. Now, one of the things that I get a lot of requests for is, I don't like to see that sudden jump. Is there a way that when I get to the end of this one, I can begin to taper to this slope, and then once I hit that slope, I can follow it? In other words, have a variable taper once I come off of the 4-to-1 slope and gradually get over to the 2-to-1 slope. How would I do that? So to do this, we're going to use a combination of everything that we've learned up until this point. And so just to review one more time, is if we have the 4-to-1 until we fall off of that, and then we go to 2-to-1 infinite. We want to maintain the 2-to-1 infinite. That's not going to change. But I want to change that one over to a priority 3. So that'll be, in other words, our last test. And so we'll apply that and keep that. And if we intersect that one where the other two fail, then that would ultimately be our final or our fail-safe solution. So what we want to do now is to shorten this one up a little bit, because I want this to continue down to here and then continue off of that point. And it really doesn't matter how long this point is. And so on the properties of this point, I'm just going to shorten this up, and we can make it longer, but it's a little bit easier to look at. So we'll just take this down to cut it in half to 2 feet. Okay, so that's our fail-safe solution, and so we'll apply that. And again, the results are not going to be any different. As you can see, as soon as we jump off of that, and I can go over here and just to kind of give you the same look and feel. But as soon as we jump off the 4, then we continue off into the 2-to-1 slope. And so you'll see how that jumps out. And we can put that back over here to there at the 4 when we get done constructing, and that's actually what I'll want to do. So how do we do this? Well, we're going to need another end condition. Now this next end condition, we're going to come over 4 feet at 0 slope, and then we're going to come down until we hit the extension of this, turn that off as a do not construct, and then connect the two with a standard component. So essentially combining what we did with the right-of-way stuff along with adding this into our solution here. And so we're going to add a new end condition, and this one I'm going to call it variable fill target. Variable fill target. And on this one, I'm going to give it the draft do not construct, because we'll never see this part of it, this piece, but we want one target. So I'm going to start at the same end condition hinge branch point, and I'm going to come over. We'll use our precision input just to keep it nice and neat, and I'm going to come over horizontally 4 feet. So 4, 0, enter, and then I'm going to come down. So we can do a DL, and again I'm going to come over 0, comma, -4. And so we'll construct our little half of a box there, if you will. And so let me move this down out of the way, and we'll right click and finish. And so now we have, you can see our little box there. And actually I didn't want to come down 4 feet. I think I wanted to come down 2 feet. So we'll change that. And that is right now. Okay. And then we want to add then essentially our tapered slope. And so that's going to just be a regular component. And I'm going to call this tapered, or variable, let's call it variable fill. Variable fill slope. So it'll be clear. variable fill slope. And again, this one, we do want the real feature on it, so we'll do a grade fill. And I want to connect this point to there, just like that. And then I want this one, I want its parent to be that end condition, which targets our active surface. And then lastly, I want to set this to do not construct. Apply that and close. And then we're going to come back here to this one to keep everything lined up. And we're going to set you back to 4 feet. So we essentially have those 2 points on top of each other. And so now when we test, we got to fix our conflicts here. So you can see that I forgot to change our variable fill target to 2. So we'll set that to 2, and then we'll close. And now when we draw our target, as we draw our target, you can see that we're not quite right in terms of we want this to variable slope, which we have, but we don't want it to go below. And also we needed to fix the priority. And so I did go back and change the priority properly. But then the next thing we need to do is come back to here, and we want to do not construct that one. So that'll get rid of our purple lines. And then down here on hinge 4, which is the end of our new segment, we do not want that to be infinite. And so we apply those changes. And now when we test, you can see that we have this priority 1 is solving. Then we go to priority 2, which is that imaginary purple line going from here to there, and then drawing the regular component back to the start. And then when that fails, because our purple down here is not infinite, then we jump over to our third segment, and now we have that variable slope. So if the ground is up here, we get our 4 to 1 slope, 4 to 1 slope. Then we vary from 4 to 1 down to 2 to 1 at a locked offset at 4 feet. And then after we get to that point, we continue on. And so that's how we can take advantage of our do not construct point and very carefully manipulating each of the endpoint properties. And so this one is checking for the interception, and we place a point at the interception, but do not construct. This one is making sure it has the interception and it places a point, but it's not infinite. And then we have number 2, which is our ultimate solution. It is infinite. And then we have point number 4 here, which is not infinite. So once it fails, it goes over to our third test. And then we have the invisible end condition here, and we'll go over to our active template, look at our branches coming off of hinge. And so here's fill slope 1. Here's our variable fill target, which comes to here and to here. So this is one continual branched end condition with one target looking for the active terrain. And you can see that it can look up and lock in at that 4 feet. Okay, and then we have this segment, which is a regular component tied on to the end of this end condition, and we made it a child of this end condition. And then the last one is the final solution. If the other 2 branches fail, then it goes down to our final solution. And so that makes use of child-parent relationships. It makes use of do not construct, and it shows you very clearly how to set priorities based on 3 particular segments, and also how to generate a varying slope depending on where your active target is at. Next thing I want to talk about is benching. So let's go over here and clear, and we're going to do a new end condition. And let's pretend like we're just going to pencil in a 4 slope and a ditch bottom. So I'll just kind of pencil something in there. So that's one target, and we'll say we don't want to check for interception on that or on this. We just always want to draw it. And not infinite. And so if we test this, it should just always draw, and it does, and that's what we want. So what I want to do here is I want to demonstrate how to do a back slope bench. So I'm going to do an add new end condition. And all I really need to do here is just turn on the bench count. It's pretty much that simple. And I'll come in here and just stencil what it is you want your back slope bench to look like. And so let's say that that's our back slope benching. Essentially the way that it works on your properties of your component, if you set it to 0, then it will go on infinitely. And so we'll go into a test here. It's just going to keep repeating that bench. And so we'll do a draw here. And because I have that point set to infinite, it can't go to another bench. And so we need to turn that off. Place that off and then apply. And then now we'll test again. So I'll bring this down. And so now as you see, as I come up, then that bench gets solved. Okay, so it just repeats. If, however, I come on to this and set a number, then it will repeat that bench 3 times and then stop. And so if I do a test now, and then there's 3, and then when I get to the end of 3, it stops. And so that is how benching works. Very simple. Essentially, it can be any configuration you want. The only rule is the first piece of the bench cannot be completely flat. If you make it completely flat, for example, if I would have made my bench start here and then come up to here, it would not solve because this first segment is flat. And now you can give it a slope of 1/100% and that's fine, up or down, depending on if you're doing a fill slope benching or cut slope benching. But just understand that the first section has to have a slope to establish the direction. So that's how we do benching. So in summary, what we've learned is every segment of an end condition must find its target for it to solve. And every segment in an end condition branch must be satisfied in meeting its target, or none or any part of that branch will draw. And so depending on how you construct your end condition depends on how many targets you need to satisfy. But all targets must be hit on an end condition branch or none of the end condition branch will work. Secondly, new information, do not use component display rules on end conditions. If you go to your section here, you will have the ability to assign a component display rule to an end condition. I would strongly suggest that you never use display rules on end conditions. Reason being, you do not have control over which order things are processed. In other words, an end condition is placed and then it is solved. And depending on what you're trying to do with the display rule, sometimes it will do what you want it to do and sometimes it won't, and you're not going to understand why it's failing. A good practice, however, is to make an end condition a child, which you can do here on your assigning a parent component that is a regular component. Let's say, for example, you have a sidewalk and a fill slope combination. If your sidewalk isn't found, then don't particularly draw that fill slope. So the fill slope could be a child of a sidewalk. That's a good example. So just keep in mind, avoid using component display rules on end condition components. It's okay to use them on regular components, but not on end condition components. But what is a good practice is to make an end condition a child of a regular component. And so that's one way that you can control whether it's drawn or not drawn. Secondly, the hinge point that we started from here, this is called an end condition branch point. And so if we go here to our end condition branches, you'll see I have one here called hinge. I can have as many starting branch points on a template as I want to. But what you don't have control over is the order at which each of those is processed. And so typically it's not necessary to have a lot of different starting branch points, but for whatever branch point there is, depending on the number of segments, you must have different priorities and tell it the order in which to test. Once one end condition branch is solved, all other ones will then be ignored. And we saw that where we talked about the priorities. Lastly, once your end condition is placed, you need to go back to each of the points along the end condition branches or segments and verify that all the properties are set to do what you expect them to do. If nothing is checked, it still does a test to make sure that the presence of the target is there. It won't look for the intersection of it. It won't place a point at the intersection. It won't be infinite. It'll just draw all the time that particular location. That's usually something you would do, for example, in the bottom of a ditch. You would just turn it all off, always draw it. And so those are just some key points to keep in mind. So the next thing we want to take a look at to conclude this video is how are some different ways that we can target points within our in-condition branch and override those initial placements. So now let's take a step back and look at that and work that into this final portion of the training.
In this video, we're going to demonstrate how we can override an in-condition where it targets a feature 3D both horizontally and vertically, as well as overriding an in-condition to target using a point control. So the first example is going to be by targeting a feature called gray daylight, and you can see that I have that as active. So let's go ahead and draw in what we want to represent as our new tie location here for our in condition. Let's just say right there. Then we want to come in and assign this a profile, so we'll open up a profile model, and that's going to give us our existing ground, and we can make that profile active. And I think for this example that's fine. So that's our active profile. It could be any profile you want to. So now we have a 3D element here, and you can see that show up in our model as well. So now we come back to our corridor. To target this, we need to add an in-condition exception. So we'll come to our corridor tool, down to our in-condition exception, and we're going to snap to the beginning and the end of that line. Accept it, allow that to process. So with this now open, we can come into our back slope, and I'm going to edit this back slope and say we want to target a feature definition both, and we'll select gray daylight. We'll apply that, say OK. And what this is going to do is going to take it away because we haven't added that as a corridor reference yet. So let's do that. So all we do is select our corridor, and we come over here to our corridor references, add a corridor reference. We select our line that we just drew, reset to complete. And now you will see that we have updated our back slope to follow that line. So that's how we are targeting a specific feature using an in-condition override. This next step, we're going to show the same process, but this time we're going to do it by point control. The nice thing about this is you don't have to do an override of your in-condition, and you don't have to add this as a corridor reference. I simply have drawn a line out here and assigned the existing ground profile to it into any profile you want to. It shows up in our model. I have our dynamic cross-section view opened up and shown in the area so that I can pick that back slope. And so if I come over here now and I select my corridor, and I'm going to go to my tools, and I'm going to add an point control, and then we're going to snap to the beginning and ending of our line to maintain our design intent. So accept that, give it a name, and the point that we're going to override is going to be this tie slope here, so we'll select that. And then our mode is going to be both, linear geometry, locate our plane element, and then allow it to process. So you can see that our cross-section updated, our model updated, and it is complete. So this is very nice. The only thing you have to be careful of is if your back slope has multiple solutions here, and you have the override going from different point names, it will only be able to pick one point name at a time. And so if you had multiple solutions through your range and you see results that don't line up all the way through, it's because you're getting different in-condition solutions with different points.